Hey there, YouTube. Today I'm going to be talking about designing a Nuzlocke AI. If you don't know, on Twitch and on YouTube I stream the whole process of creating all sorts of different AI projects, and this is just going to be a shorter form video about the kind of design process for one of the major projects we're working on right now, which is creating an AI that can play Nuzlocke Pokemon games. In this case, we're focusing on Pokemon Black, which is my personal favorite Pokemon game. Gen 5 was one of the first gens that I spent countless hours in. I've played it and replayed it so many times at this point I know it like back of my hand. I've played challenge versions, Nuzlockes of it, and what I found is I'm really bad at Nuzlockes. And so I decided to create a Nuzlocke AI. I'm a machine learning scientist. I work in Tokyo, so I figured I'll use my skill set for the greater good and never have to play a Nuzlocke again by creating an AI that can do it for me. So this video is just going to be about the design process and what is involved in doing this, because while Pokemon is a game primarily played by children, designing an AI that can play it well instead with a lot of challenge rules is not trivial. So we'll be walking through the different steps that we need to take in order to do this and just give a better picture of what the project is. So without further ado, let's dive in, shall we? So what is a hardcore Nuzlocke? So we're not just playing Pokemon, and we're not just trading an AI that can play Pokemon. We're gonna play Pokemon like people who have no lives play Pokemon. It's going to be Pokemon with permadeath, only capturing the first encounter on each route. If you lose a battle, you lose the run and you need to restart. No items in battle except for held items. We're playing on set mode, which means when you knock out an opponent Pokemon, if you're playing on Switch, it'll give you a little prompt saying, oh, the opponent's going to send out this, what do you want to switch to? But we're playing on set, so that doesn't happen. If you knock out an opponent, they send out what's coming next and you don't get to just have a free switch. We're playing with level caps. The way we'll be doing this is just generally you can't over level the next gym leader's ace, and in the case of Pokemon Black it'll be the last or the ace of the typical Elite Four member. We're also playing with Species Clause, which means no duplicate encounters. If you catch a Magikarp in one route and encounter a Magikarp in a second route, then you just re-roll your encounter and you can catch something else. We're not playing it harshly with Species Clause. It's not like you just lose the encounter, but it kind of allows for some strategizing about encounters and the order. So that's kind of the gist of a hardcore Nuzlocke. The hardcore part is all of these extra restrictions of no items, set mode, level caps. But the other rules like permadeath and encounter catching is your typical Nuzlocke. So hopefully by the end of this, we'll have an AI that can follow all of these really restrictive rules that even for a grown adult who has played Pokemon a lot can be very challenging. I have not won a successful hardcore Nuzlocke of Pokemon Black. So then where is the AI? And in this case, actually, this process calls for kind of two different ways of using AI. In our case, we're going to be splitting it into two parts. Team building AI, which will be using machine learning to come up with, out of our available options, what's the best team we can put together for the next battle. Basically, the way that we'll do it is we'll create a model that can predict how good a team will be by giving it the predicted ELO of the team. Then we'll use genetic algorithms to, out of the random options that you could have in your team, to kind of find the best one. It'll predict how good each of your options are out of a sample, take the best teams, merge them together, swap things around, and so on and so forth. Then, for the obvious part of the AI is battling. We need it to be able to choose the best move to get the best result in the battle at any one time, whether that is using an attacking move or switching. Since we are banning items, it actually makes the process simpler, because since it's not allowed to use items, we don't have to program support for items. And this is going to be involving a lot of what's known as reinforcement learning. So we'll be simulating lots of battles for it to make moves in, fail, learn from it, and so on and so forth. So we'll go into these two in more detail, but that's where the AI is. The rest of what we're doing is not AI so much as it is simulation, which serves a purpose to allow us to train both of these models in AI. So the next one, and just as I said, we need to be able to model the run. So what you could do is you could pull up an emulator or an actual DS and run Pokemon Black on it and try to train the model that way. If you were using a physical DS, you could write some code where the opponent uses some move, you tell the computer that the opponent used that move, it decides to move back, so on and so forth. That would be very, very, very slow. So instead what we're doing is we're using Showdown to simulate battles. So what we're going to do is we're going to actually create a big, basically Excel spreadsheet of all of the battles and encounters that happen in a run of Pokemon Black. And it will go through one at a time, row by row. It'll draw a random encounter from the available encounters at that step, if there are any. It will do a phase of team building using its new encounters, plus all the existing Pokemon in its box. It'll do the battle using Pokemon Showdown. So we will have an AI opponent that's like the game AI, and we'll have the AI player, which is our kind of reinforcement learning AI. And we'll simulate the battle between them. Based off the result, if certain Pokemon have died, then we will log that and remove them from the available options for next time. If they lost, then the run is over, and we just stop there. Otherwise, we move on and repeat. And this process goes over and over and over again throughout the entire run. For the full run, there's hundreds of battles that need to happen. But so far, we have, in our Twitch stream, got it working up to Gym 2, which is at 40 battles or so. And it's able to repeatedly win Gym 2. So we're well on our way to having a good process. And this flow is the general run simulator. In the end, we will kind of ditch this modeling of the run and have it do off of a real game on stream. And I'll also make an edited down video of that on the YouTube. So check it out, subscribe if that's something you're interested in. And once that's ready, it'll be posted to this channel. Next, let's talk a little bit about the two different AI components, which are the team building AI component and the battling one. So let's start with the team building AI. For the team building AI, the general process is basically this. We are going to have a random battle simulator, which we've actually already got working, that will simulate millions of random battles between teams. It will basically generate 1 million random team players, and each of those players will use the same team for all of their battles. We will have them battle each other just for days on end of doing battles. A battle typically takes like 3 seconds to run, so we can easily simulate millions of battles. And this, at the end of it, will give us an ELO rating of each player. This basically is like where they stack up on the ladder against each other. So we can see the best resulting players compared to the worst resulting players. This becomes our training data set to then create a team ELO predictor. What this does is it just takes in the team that you have, like an input team, and it tries to predict what the ELO of that team would be. We can then use that ELO predictor as a function to try to find the best team given our options. So if you have 30 Pokemon as your options, with tons of different moves that they could have and abilities and orders on the team, you'll have trillions of possible teams. So we can't just score every possible team and choose the best one. So instead what we'll do is we'll actually take a random sample of those possible teams, score it using the ELO predictor, take the best team or teams, randomly modify it, and repeat. And do this kind of sampling process until it stops finding a better team. And once it no longer can find ways to improve that team, that'll be the team to use. This is known as a genetic algorithm. It's not really illustrated too much on that flowchart, but that's the idea. We're kind of searching for what is the best team because it's impossible for us to just score every possible team. So instead we have to get a little bit creative by creating a bunch of random teams out of the possible ones, score them, do some kind of merges, just like you would see in some sort of, evolutional cycle, and find the best team that way. Once we've found the best team, then it's time for battling. For the battling AI, this is a little bit more complicated than the other one. So what we need to do is we again need to simulate millions of battles. And the reason why we're needing to simulate some battles in advance is we want to get a kind of pre-trained AI that knows the basics of what's going on. It needs to understand what the columns are, so what the different Pokemon are, what types they are, and some just general information about the moves. And when we simulate millions of battles just using a random battle simulator, that's very, very, very fast. A single battle takes less than 3 seconds, and we can do hundreds at the same time even. So it's not even just one at a time, but hundreds at the same time, which allows us to get a huge amount of data in advance. We can then use that to train an initial model before we start the reinforcement learning. It saves us a huge amount of time, and we can kind of skip over that phase of the model's just doing nonsense because it just was initialized. Once we've got that pre-trained model, then we'll feed it into the real battle simulator. And this is where we can actually do some more interesting things, like feed it real battles from real opponents on Pokemon Showdown. All of the Pokemon Showdown stuff up till now would just be a local version of Pokemon Showdown, where we can spam it with as many requests as we want because we're hosting it. But what this would allow us to do is, since reinforcement learning is very serial in nature, so it's one at a time. You just do one battle, analyze the results, improve the model, do the next battle. We can actually have these be real battles against real opponents. Since this is already going to be a slow loop, and the model's already pre-trained a little bit, this would give us real information on how good is the model. And once we get a model that works well against real opponents, we could even challenge some other YouTubers and other Twitch streamers to see if they can beat our battling AI. So this will be a really interesting part of the project, and if you're interested in that part specifically, that's what we're going to be tackling next on stream. So tune in this upcoming Tuesday if you're watching whenever the video is first posted, because that's where we're going to first be tackling this component of the AI. Alright, and so that's about it for this video. I just wanted to put together a quick summary of this project and what's going on. I've seen a lot of questions on Twitch and on YouTube during the VODs about what this project is or what we're doing for it. So I wanted to put together a basic summary of all the different things that we're doing. And hopefully it paints a better picture of the whole project. If you like this video and you want to see more like it, consider subscribing. I am going to be posting more videos about the project. In fact, the next video that I'll be making is about our journey to beating Gym 2 and what we did to get it working. And I'll also be posting some general tutorial videos, like how do you learn machine learning and what resources are out there and what I would recommend. If you have any ideas for videos you would like to see, please let me know in the comments. If you like this video, leave it a like and subscribe, and I'll see you next time. Thanks for watching.